Okay, now let's begin to take a look at our code challenge. Our first step will be to import the pandas library and assign it as the alias PD. Here we can see import pandas as PD. So now when we refer to pandas, we'll be calling it PD. Our next step would be to use pandas to read in the first dataset in its CSV format as a pandas data frame. We achieve this with the .readCSV method here from pandas, and we assign it the stocks1 variable to the CSV file, and we are able to view our file here by simply calling it. We do the same with our second data frame. With the read CSV method, we assign it to this variable stocks_2, and we view that as well by simply calling the variable. Next, we like to use merge to combine the two datasets into a single dataset. Much like the SQL join methods, we define the left and right datasets and choose a shared column to merge the two datasets on. The only shared column in this case is the broker column. We can see broker here is in both of the datasets. So we're going to merge on broker. So we set this to on within our merge method. And when we call our new data frame, we can see that the two data frames are combined into the one. We see here the values from the first and the values from the second. So we'd like to consolidate the values for the day variable. These values, Monday, Tuesday, Wednesday, Thursday, are values of the day variable. So we want to consolidate those using the melt method. We're going to assign broker values and stocks as the ID vars to be the identifiers of each row. We can set these three identifiers in this case, not so much to make them the indices of the data frame, but more so to not lose the information during the transposition. We'll also set the var name to day, as each of the days that have value in the column. And lastly, we'll set the value name to amount, as these are the values associated to the high and low amounts of each portfolio for each day. And when we take a look at the resulting data frame, we can see that we have now the broker column, the values column, still the same, but here we see days are no longer the values are no longer individual columns, but they all belong to this single column of day here. Next, we will use the pivot table method to transform the high and low row values into columns. So we're going to assign broker, stocks, and day to indices, as these columns do not need to be transformed. We're going to set values as the columns, as we want the values high and low to be their own columns. And lastly, we'll set the new column amount as the values that represent the high and low values of each of the brokers. When we take a look at this resulting data set, we can see now, although we have a hierarchical data set, where we can see the broker Harry here and the broker Heather here, all of their days, the high and low values for each of the day, we see at least that the values, the variables high and variables low, have their own unique columns, and that's what we're looking for with the pivot table method. So to resolve the hierarchical structure here, we're going to use the result index in place equal to true to change the index structure and set that in place. we will take a look at that resulting data frame, and now we can see that we have all of the calls of each of the brokers. And lastly, we like to set the index to not be values. You see here we have this values. We no longer need this column. This doesn't need to be our index anymore. So we can just set the list names of the columns to be empty, and we have a resulting data frame that we're looking for with the high and low variables as columns, the stocks being associated with each broker, and the day values belonging to one day column.